everyone, welcome to Quality Quant Questions, week 18. This week we'll be tackling questions around logarithms. First one, basic logarithm question. Now, for log, definitionally, log b to the base a equal to c. What this means is, this is an alternate representation of indices. A raised to the power c should be equal to b. Just utilizing this insight, 8 raised to the power 0 should be equal to this, and 8 raised to the power 0 is 1. So we'll reduce it to 5 raised to the power log 3x is equal to 8 raised to the power 0, which is equal to 1. Now, this can be further simplified as log x to the base 3 is equal to 5 raised to the power 1, which is equal to 5 alone, which can be further simplified as x is equal to 3 raised to the power 5, which is 243. And we have our final value of x, 243, identified. Next, if x, y, z are consecutive positive integers, which of the following is the value of log x, z plus 1? Okay. Now, there are two ways of doing it. One is algebraically, one is value fitting. Algebraically, you can see x, y, and z, if I have, these are three consecutive positive integers. So, x will be y minus 1, z will be y plus 1. So, when I'm looking at xz, I will be getting y square minus 1. X into z is y minus 1 into y plus 1. Therefore, y square minus 1. Or this term will simplify to log of y square. Y square minus 1 plus 1 cancels out. This 2 will come to the front. We'll have 2 log y, which is option D. We can mark it this way. This is the more technical way of doing it. The other way of doing it is, why even bother with doing all this? Let us take three simple consecutive numbers. Let us take three simple consecutive numbers. So we'll have log xz plus 1 as log 4, which we know to be 2 log 2. Now see, this option gives me log 6. We don't need this. This is not right. 0 is of course not the value. This is 1 minus log 2. And this is 2 log 2. Among the available options, clearly D works. Fitting in values is also perfectly acceptable. Doing it technically is also perfectly acceptable. Next, this is more language-based tuning. If the logarithm of x to the base equal to square root of y is 2, log x to the base square root of y is equal to 2, what is the logarithm of the cube of x to the base equal to cube root of y? Finally, we are looking for x cube to cube root of y. We are looking for this value. First, let us simplify this. This under root y will come out and become 1 by half log x to the base y is equal to 2. If this 2 goes, this half will make this 2 go to the top. And this 2 and this 2 will get cancelled. I'll have log x to the base y is equal to 1. This is wonderful. Now let's simplify this. This 3 will come here. And 1 by 3 will come to the base. I will have log x to the base y. This 3 will go to the top. I have 9 log x to the base y. And we know log x to the base y is equal to 1. This will simplify to 9 only. And the answer of this question will be 9. Next, if log 3 to the base 4, log 3m minus 2 to the base 4, and log 3m minus 8 by 3 to the base 4 are in AP, then the number of possible values of m is. Now pay attention, if we've got log a to the base n and log b to the base n and log c to the base n, if these three terms are in AP, it means A, B, C are in GP. how that figures? See, if these are in AP, this term, if this is equal to K, if this is equal to, let's say, if this is equal to K, this is equal to K plus 1, and this is equal to K plus 2, because they are in AP, 3 consecutive numbers I've taken. A is equal to n raised to the power K. B is equal to n raised to the power K plus 1. And C is equal to n raised to the power K plus 2. Can you see? From A to B to C, in order to move from A to B to C, you simply need to multiply it by n. A, B, C are in GP. Once that is known, we can do our subsequent processing here. If 3m minus 2 and 3m minus 8 by 3 are in AP, sorry, 3m minus 2 and 3m minus 8 by 3 are in GP, it would be in the middle term square. 3m minus 2 whole square has to be equal to 3 into 3m minus 8 by 3. Now, at this time, it may seem like, therefore, there will be two values of m, and we can go ahead and mark. There will be two possible values of m, but you cannot do that. Especially in log-based question, be very, very mindful. We have to come up with we will come up with the two values of m that this quadratic equation gives us, but then we also have to go back and check 3m minus 2 has to be positive. 3m minus 8 by 3 has to be positive. If they are not positive, then the logarithmic terms will not be defined and that value of m will get rejected. That additional step is still in play that you have to take care of. Let us open it up. I get 9m square plus 4 minus 12m is equal to 9m minus 8. Bringing everything over to this side, 9m square minus 21m plus 12 is equal to 0. I can cancel out the 3. I can get 3m square minus 7m plus 4 is equal to 0. So 3m square minus 3m minus 4m plus 4 is equal to 0. 3m taken out. I get m minus 1 minus 4. M minus 1 is equal to 0, or 3m minus 4 into m minus 1 is equal to 0. So m is equal to 1 or m is equal to 4 by 3. M is equal to 1 or m is equal to 4 by 3. These two ways exist. Now we have to go back and check. 3m minus 2, 3 minus 2, would this be fine? Okay, here 3m, I would have, when m is equal to 1, the series would be log 3, base 4, I'm not worried about, log 1, and then I will have log 1 by 3. Yes, all three of them are positive. So m is approved. M is approved. Otherwise, we will have log 3, log 2, log 3m will be 4 minus 8 by 3, 4 by 3. So 3 into 2 by 3 into 2 by 3. Yes, these are also positive. So both of them are approved. So the number of possible values of m will be 2. You cannot say 2 at this point itself, because maybe this solving leads us to, let's say, m is equal to minus 1. If it leads us to, let's say, m is equal to minus 1, then this log term and this log term will not be defined at all. We should make it an unacceptable case. So currently, both of them are acceptable values of m, but it is not willy-nilly that we can mark 2. Okay, next question. Log 162 to the base x is equal to m. And log 72 to the base n is equal to n. What is the value of log 7776 in terms of m and n? Okay, first let's break this down. Log 162, I honestly don't care for base x because it is same everywhere, is equal to m. Can I go on to say Therefore, this will be log 81 plus log 2 or 4 log 3 plus log 2 is equal to n. I've got this. Okay. The other working I have is log 72 is equal to n. So I'll have log 8 plus log 9 is equal to n. So 3 log 2 plus 2 log 3 is equal to n. Now this final 7776. Now this, some of us may recognize it, some of us may not recognize this. This is 6 raised to the power 5. 1296 into 5. With that known, I can say log of 7776 will be equal to 5 log 6, which can be written as 5 log 3 plus log 2. We need this eventually. We have some presence of log 3s here. We have some presence of log 2s here. We have some presence of log 2s here. We have some presence of log 3s here. We need 5 log 3 and 5 log 2 eventually. We need 5 log 3 and 5 log 2 eventually. Okay. Now, we have to check options. M plus 3n. Instead of looking at the full thing, just see for log 3. M will give me 4 log 3. 3n will give me 6 log 3. 4 log 3 and 6 log 3. Okay, 10 log 3. Divided by m plus 5n. Here I will get 4 log 3 and here I will get 10 log 3. So I was getting 10 log 3 by 14 log 3. How will I ever reach 5 log 3 in the numerator with nothing in the denominator? Doesn't make sense. This option gets ruled out. Let's go to this one then. I have 3m. 12 log 3 minus 5n 10 log 3. 12 log 3 minus 10 log 3. Numerator has 2 log 3. Denominator has 4 log 3 and 4 log 3. So 2 log 3 by 8 log 3. 1 by 4 log 3 by 4 log 3 will continue to remain. I can't work with this anymore. Goes away. Let's look at m plus 3n. 4 plus 6. 4 plus 6. 10 log 3. Denominator has 2. Ooh, I will get a 5 log 3. This seems promising. Let's also look at log 2 now. After I have done my check for log 3, I will now do my check for log 2. M plus 3n. So from here, I get log 2. From here, I'll get 9 log 2. Log 2 plus 9 log 2 adds up to 10 log 2. And 10 log 2 divided by 2 will give me 5 log 2. I'm getting both my 5 log 3 and 5 log 2 in option C. And therefore, this will be the answer. For peace of mind, you can also go ahead and check option D, but it will turn out to be unequal. The process here is, first you break down 162, then you break down 72, then you break down 7776, and then you have to check through the options. And even while checking through the options, first you check it only via log 3 or only via log 2, whichever one you prefer. Then when you arrive at a spot where log 3 is being satisfied or log 2 is being satisfied, then you check for the other one. If it is also being satisfied, that is your answer. You don't need to check any further. Okay. Next question. For how many positive integer values of x less than 100 is 4 log 5x 4x minus 15 divided by 5x or to the base 5x is greater than equal to 0.5. I can write this as log of 4x minus 15 is greater than 1 by 2. This 2 I can bring over to the left hand side, which will give me 2 4x minus 15 is greater than 1. This 2 I can also bring in here, get rid of it, and then I will have 4x minus 15 whole square should be greater than 5x raised to the power 1. This is a normal inequation. Let us solve. I'll get 16x square plus 225 minus 120x is greater than 5x. I can bring this 5x over here. I'll get 16x square minus 125x plus 225 is greater than 0. Now trying to factorize this, 16 into 225 has to be broken down into two numbers that add up to 125. Let's see, 16 into 225 into 5, if I get it to 80, I can get it to 45. And yes, these two add up to 125. So I have 16x square minus 80x minus 45x plus 225 is greater than 0, which gets me 16x x minus 5 minus 45 x minus 5 is greater than 0, or 16x minus 45 and x minus 5 are supposed to be greater than 0. So now on the number line, if I try to represent it, 5 and 45 by 16 will be 2 point something 8275, something like that, 2 point something. Every number in this region will be deemed acceptable. Every number in this region will be deemed acceptable. This will not be acceptable. This will not be acceptable. The boundary points will not be acceptable, and anything in between will also not be acceptable. And it may seem like, see, here we have 1. We were looking at only positive integer values, no? So here we will have 1 and nothing in between, and then 6 to 99. 1 and 6 to 99. So how many values do we get? 1 from here, 6 to 99 from here, which is 99 minus 5. Altogether, we will have 95 values. Which values are being removed? 2, 3, 4, and 5. From the first 99 numbers, these 4 numbers are being removed. And it may seem like this is our answer. But this is the best trap answer. This is the best trap answer. Because remember, whenever it is a log term, this portion has to be positive. 4x minus 15 has to be positive. We have another condition playing. 4x minus 15 has to be positive, or x has to be greater than 3.75. X cannot be 3.75. So this one that can get considered by mistake should not be considered. Only values after 3.75 have to be considered, and they will be 6 to 99, or the number of positive integer values that x can take is 94 for this question. The correct answer to this question will be 94. Okay. Next. If x is greater than 1, find the minimum value of this. Minimum value has been asked. Okay. So I have log x cube by log 20. I have log x cube by log 20 minus, if I have minus, I can't really do that now. Right now, I will have to do log x. Okay. This is as good as 1 by 8 or 2 raised to the power of minus 3. 2 raised to the power of minus 3. So, let me rewrite these terms. First, I will write down log to the base x, 10 raised to the power 3 is 1000. And then I will divide it by 2 raised to the power minus 3. 2 raised to the power minus 3. So I can bring it to the top. I can bring it to the top. This is minus 3 right now. So it will turn to log x 8000. Okay. Very nice. Very nice. Very nice. See what this gives me. I have 3 log x to the base 20. 3 log x to the base 20 plus this 80 is 20 cube. So I can write it as 3 log 20 to the base x. So I have this term and this term, which are reciprocals of each other. So I have 3 times of a plus 1 by a. And this is a term that is very, very popular, very, very familiar to us. A plus 1 by a, when a is a real positive number, minimum value of this is minimum value of this is 2. We know when log values are being talked of, minimum value, it will always be a positive real number. So the minimum value of this entire expression will be 3 into 2 or 6. Answer to the question will be 6. Next, given that log 3 is equal to 0.4771 and log 2 is equal to 0.3010, find x if x is greater than 0 and 5 raised to the power x into 27 raised to the power 1 minus x is equal to log, okay, 0.01. Okay. Now if log 2 is equal to this, we know log 10 is equal to 1. So log 10 minus log 2 will be 0.6990. And log 10 minus log 2 is as good as log 5 is equal to 0.6990. I also have this habit of writing down this fourth 0 because if I don't, I end up making mistakes. I don't know if that is the case with you, but if it is, write down this fourth 0 for log 2 and log 5. The scope for error will go down. What this enables us to do is, now I can take a log on both sides. It will get me a log on both sides. So I will have x log 5 plus 1 minus x log 27, which I can rewrite as 3 raised to the power 3. So this 3 will come out here and I'll be left with log 3. And this is equal to log of 1 by 10. Now see, log 10 is 1. Log 1 is 0. Log of 1 by 10 is equal to minus 1. I know the value of log 5. I know the value of log 3. I also know the value of 1 by 10. So I can replace it in entirety. I will have 0.6990x plus 3 times of 1 minus x into 0.4771x is equal to minus 1. Okay. So I will have to first break down this 3 minus 3x. 3 minus 3x and 3 into this 0.6990x plus 3 into 4771. So 3, 1 carried over or 2 carried over. So 3, 2 carried over. So 1.4313. 1.4313. You got this much minus 1.4313. 4313x is equal to minus 1. This minus 1 should come here. The difference should go here. So I got 2.4313 and 3 minus 0 gets me 3. 1 minus 9 gets me 2. 1 minus 9 gets me 2. 2 minus 9 gets me 3. 3 minus 6 gets me 7 and 0 minus 0. So 0.7323x is equal to 24313. And from this, I can see x has to be greater than 3. I can get rid of the decimal spots. I can see 7,000 into 3 is 21,000, but this is more than 24,000. So my answer has to be greater than 3. Among the available options, the only one that fits is option D, and therefore I'll mark D. Otherwise, I can, of course, always go on to use the calculator in order to arrive at the answer. Okay, then this one now. Log A, B, C, D are integers, satisfying. Log A by log B is 2 by 3, and log C by log D is 4 by 5, and C minus A is equal to 7. Yeah, I can go log A to the base K by log B to the base K is equal to 2 by 3, and log C to the base N by log D to the base N is equal to 4 by 5. This gives me an indication C has to be equal to N raised to the power 4, and A has to be equal to K raised to the power 2. Now, difference between a perfect power 4 and a perfect square is given to us as 7. Can you think of any case? Can you think of any case? Very simply, the best case you can think of is C being equal to 16, which will lead to N being equal to 2, and A being equal to 9, with K being equal to 3. Difference is this. This is so wonderful. This is absolutely wonderful. What this also enables us to identify is now D will be 3 raised to the power 5. 3 raised to the power 5. Sorry, 2 raised to the power 5. D will be 2 raised to the power 5. N raised to the power 5. And B will be 3 raised to the power 3. This is 32. This is 27. These values are uniquely identified. Finally, we are asked, what is B minus D equal to? B is 27, D is 32, B minus D will be equal to minus 5. B minus D will be equal to minus 5. Okay, absolutely wonderful. Another way you can choose to potentially solve it is very algebraic. Another way you can choose to solve this is very algebraic, but I don't want to go down that path. This is good enough. This is identifying difference between a perfect power 4 and a perfect square is being 7. That is definitely within our wheelhouse, and we can solve this one here. Okay, this one now. A, B, C, D are positive quantities such that A square is equal to B cube is equal to C raised to the power 5 is equal to D raised to the power 6. Now, finally, we need this log of A, B, C to the base D. So our work should be to represent A and B and C in terms of D. A will be equal to D cube, B will be equal to D square, and C will be equal to D raised to the power 1.2. So this will simplify to log of D raised to the power 3 plus 2 plus 1.2 to the base D. This will come out 6.2 log D to the base D, which is equal to 1, or the value of this will be equal to option D, 6.2. Okay. This is interesting, extremely interesting. Let's see. Log of x cube plus y cube minus log of x square minus xy plus y square plus log of x cube minus y cube minus log of x square plus xy plus y square is equal to log 247. How many integral values can xy have? Pay attention, there are modded terms involved, and then expansion of a cube plus b cube versions are also involved. First, I'm writing everything combined. I have mod of x cube plus y cube and mod of x cube minus y cube, whole thing divided by x square minus xy plus y square and x square plus xy plus y square. This is equal to log 247. At this time itself, I can get rid of the log. I can happily get rid of the log. Log serves no purpose from here on out. And we don't say we cancel out log, we take anti-log on both sides. Our work will be valid. Now from here, x cube plus y cube will get simplified to x plus y mod into x square minus xy plus y square whole mod. And x cube minus y cube whole mod will get it to x minus y whole mod and x square plus xy plus y square whole mod, whole thing divided by x square minus xy plus y square whole mod into x square plus xy plus y square whole mod is equal to 247. Now this is wonderful. I can get rid of this and this. I can also get rid of this and this. And finally, we are left with x plus y whole mod into x minus y whole mod is equal to 247. 247. Now see how this subsequent solving will break down. We know two numbers are multiplying to give us 247. So it can either be 247 into 1 or it can be 247 is 13 into 19, no? Yeah, 13 into 19. So it can either be 19 into 13 and it can be 13 into 19 and it can be 1 into 247. Each of these cases are possible. Each of these cases are possible. Now, see, for each of these cases, right now, I have taken both the numbers as positive. I've taken both the numbers as positive. For every solution set where A and B are positive, I identify. There will also be a solution set of the form minus A comma B. There will also be a solution set of the form A comma minus B. There will also be a solution set of the form minus A comma minus B, because x plus y and x minus y both are modded terms here right now. Both are modded terms here right now. So for each of these solution sets, there are going to be 4 cases. In order to visualize it, I'm going ahead and showing you for two, let's do it for 13 and 19. 13 and 19. So x plus y being equal to 13 and x minus y being equal to 19, one case. Another case, x plus y being equal to minus 13 and x minus y being equal to 19. Another case, x plus y being equal to 13 and x minus y being equal to minus 19. And finally, x plus y being equal to minus 13, x plus y equal to minus 19. Here we will get 2x is equal to 32. So x is 16 and y is minus 3. One solution set is obtained from here. Next, 2x is equal to 6. So x is equal to 3, y is equal to minus 16. Yup. From here, 2x is equal to minus 6. So x is equal to minus 3 and y will be equal to 16. Y will be equal to 16. And here, 2x is equal to minus 32. So x is equal to minus 16 and therefore y will be equal to 3. Hopefully the generation of cases also shows you these two cases are simply the positive and negative values are interchanging. And these two cases are simply the positive and negative values are interchanging. Same for every pair that we've identified, there are going to be 4 cases like this. Or how many integral values can xy have? The answer to the question will be 16. Okay. Then find the sum of the series. 1 by log 9 to the base 3 plus log 9, 1 by log 9 to the base 9 plus 1 by log 9 to the base 27 all the way up until plus 1 by log 9 to the base 3 raised to the power n. Now we can solve it technically, we can solve it smartly. Technically, it would be, first thing, we need everything being, the base being identical, everything, we need base being identical. If base has to be identical, instead of looking at it in the reciprocal form, let's invert it. We'll have log 3 to the base 9 plus log 9 to the base 9 plus log 27 to the base 9 plus log 3 raised to the power n to the base 9. Now, because of base 9, every term will have a half outside. So I can simply take half outside, turn this into log 3 to the base 3 plus log 9 to the base 3 plus log 27 to the base 3 plus log 3 raised to the power n to the base 3. Now this is 1, this is 2, this is 3, all the way up until n. So this is sum of first n natural numbers, which will begin by half into n plus 1 by 2, or final answer being n plus 1 by 4. Or option D will be the answer. We can solve it this way. This is the technical way. Another way we can potentially approach this is, let's take n equal to 1. If this series is going to be valid for n terms, it is also going to be valid for one term. It is also going to be valid for one term. Let's put down n equal to 1. So only for first term, it is as good as log 3 to the base 9. This will be equal to half. Let's see, when I put n equal to 1, is there any option which gives me half? N into n plus 1 by 2. N into n plus 1 by 2. This is 1 into 2 by 2. This gives me 1, is ruled out. This is 2 by 1 into 2. This also gives me 1. This is ruled out. Option C, I have 1 into 2 into 3 divided by 12. Ooh, this does give me half. And n into n plus 1 by 4, this also gives me half. So this is very serious. Option C and option D, both of them are giving us half. We know that these two survive. So instead of taking n as 1, let's start taking n as 2 now. First term was half, second term is 1. If I invert it, I will get 1 from here. So I should get 1.5. If I take n equal to 2, I should get 1.5. C will give me 2 into 3 into 5 by 12, which is equal to 2.5. But I needed 1.5. This is gone. Option D, C. 2 into 3 by 4 does indeed give me 1.5. So answer should be option D. Now, one more generic piece of advice. See where you have to check in values now. Where you have to check in values. More often than not, the question setter is smart enough that plugging in n equal to 1 will not work, or it will work in multiple options. So the smart thing, and this is something you learn from experience, smart thing is plug in n equal to 2 directly. Plug in n equal to 2 directly, then you wouldn't have to do the work again. There, whatever option you're getting will usually be the right answer. Wherever it is satisfying, that will usually be the right answer. Okay, let's look at this now. We've got log x to the base y is equal to a, and log y to the base z is equal to b, and log z to the base x is equal to a into b. Y raised to the power a is equal to x, z raised to the power b is equal to y, or can I go on to say z raised to the power ab is equal to x, z raised to the power ab. Utilizing these two, I get z raised to the power ab is equal to x. And from this is wonderful. This tells us x raised to the power ab is equal to z. How can this be? Let me replace z with x raised to the power ab. So I'll have x raised to the power a square b square is equal to x. How can this relation hold? It can only hold if a square b square is equal to 1. A square b square is equal to 1. Now, they're asking me which of the following pairs of values for a and b is not possible. If a is 2 and b is half, AB will be equal to -1. Then will a square b square be equal to 1? Yes. So this is possible. 1, 1. AB is equal to 1. Will a square b square be equal to 1? Very much so. 0.4 and 5, 2.5. See, 0.4 is 2 by 5. 2.5 is 5 by 2. Of course, it is equal to 1. Their square will also be equal to 1. But what remains is 2, 2. AB is equal to 4 here. So will a square b square be equal to 1? No. So which of the following pairs of values is not possible? It is option D. Next, if x is greater than y and y is greater than 1, then the value of the expression, let's see, log x upon y to the base x plus log y upon x to the base y. Which of the following values? It can never take. Okay. First, I will open it up. I will get log x to the base x minus log y to the base x plus log y to the base x to the base y minus log x to the base y. This we have. Okay. Now see, this is equal to 1. This is equal to 1. So these two I will combine and write 2 minus log y to the base x minus log x to the base y. Can I write it as 2 minus log y by log x plus log x by log y? Remember or observe, they are simply reciprocals of each other. And we know for two real numbers, the number and the reciprocal, minimum value of this will be 2. So can I say the value of this entire expression will be less than equal to 0? Value of this entire expression will be less than equal to 0 because the minimum value of the bracketed portion is going to be 2. Given that the value of this entire expression will be less than equal to 0, which of the following values the expression cannot take will be option D, 1. Okay. Let us now go to characteristic and multi-saw work. Okay. What is the number of digits in 2 raised to the power 50? Now, number of digits is given this way. See, you take log of this, log of 2 raised to the power 50, which will convert to 50 log 2. Now, log 2 value we know is 50 into 0.301. So I have 15.03 obtained here. Now this tells us the portion ahead of the decimal. The portion ahead of the decimal is for positive numbers. The portion ahead of the decimal is 1 less than the number of digits in the number. How many digits are there? 1 more than 15. There are 16 digits here. There are 16 digits in this. Now, for the numbers that are less than 1, numbers that are in decimals, the working is slightly different. The initial steps will be identical. Log of 2 raised to the power minus 50. And then this will turn to minus 50 log 2, which will get us to minus 15.03. Now remember, this is the mathematical value. This is not the log representation. The log representation of this is the log representation of 2 raised to the power minus 50, log of 2 raised to the power minus 50. And how is this obtained? The number prior to the decimal point, is one more than the number of zeros after the decimal point and the first significant digit after the decimal point. This 16 is one more than the number of zeros from the decimal point to the first significant digit. Answer to the second question is 15 digits. If you are ever wondering why this works, you can potentially observe, see, log 10 is equal to 1. Now log 100 is equal to 2. Can I say all 2-digit numbers can be represented as 1 point something something? All 2-digit numbers from 10 to 99, everything will be 1 point something something. Similarly, when I go to log 1000, this is equal to 3. So all 3-digit numbers will be 2 point something something. All 3-digit numbers will be 2 point something something. Or if you go all the way up until log 10,000, this is equal to 4. All 4-digit numbers will be 3 point something something. Basically, when we are dealing with log 10, when we're dealing with a base of 10, the value increases by 1 whenever we cross the next power of 10. Until the time we cross the next power of 10, the value does not increase by 1. So, 1, 2, 3, so on and so forth. For positive side, it is very easy to see because you've seen it very many times over. For the negative side, let's see, log 1 is equal to 0. This everyone knows. Now log of 1 by 10 is equal to minus 1. Then log of 1 by 100 is equal to minus 2. Log of 1 by 1000 is equal to minus 3. And log of 1 by 4 zeros, 10,000 is equal to minus. But remember, log values are never represented as negative. So how this will get represented? Is 1 bar 0.0000. This will get represented as 2 bar 0.0000. This will get represented as 3 bar 0.0000. Here it will be 4 bar 0.0000. So now every number from 1 by 10 to 1 by 100 will be 1 bar point something something. 1 bar point something something. Here it will be 2 bar point something something, 3 bar point something something, 4 bar point something something, so on and so forth. Here the count of digits, see, representation wise, the count of zeros after the decimal spot, it is dependent on the negative power of 10. Here it is dependent on positive power of 10. Either you can commit it to memory or you can go ahead and see the examples. The representation and the number formation is going to be very, for a small concept, it is going to clarify it in entirety. Okay, moving on to the next question. We got this log x to the base 10 minus log root x to the base 10 is as good as log x to the base 10 minus half log x to the base 10 is equal to log 100 to the base x. So we can potentially get it to half log x by log 10 is equal to 2 times of log 10 by log x. So log x whole square is equal to 4 times of log 10 whole square. Okay. So I can get this log 10 whole square, I will bring here. I will get log x to the base 10 whole square is equal to 4. So log x to the base 10 is equal to 2 or minus 2. So x will be equal to 10 square or 10 raised to the power minus 2. This gets us to 100. This gets us to 1 by 100. So then a possible value of x is given by 1 by 100. This will be accurate. Okay. Another fun question. Log x is, let's work. Log x by b minus c is equal to log y by c minus a is equal to log z by a minus b is equal to k, which is not given. We introduce it. So log x is equal to k times of b minus c, and log y is equal to k times of c minus a, and log z is equal to k times of a minus b. But this is not the end. We take another variable t here to the base t, everywhere to the base t. This gives me x is equal to t raised to the power kb minus kc. This gives me y is equal to t raised to the power kc minus ka. And this gives me z is equal to t raised to the power ka minus kb. So if I get x into y into z now, if I get x into y into z now which of the following are correct? First one I'm checking, x into y into z. If I multiply all these, the powers of t will add up. This plus kb will cancel out with this minus kb. This minus kc will cancel out with this plus kc. This minus k will cancel out with this plus k. So xyz being equal to 1 is valid. This is definitely true. This is most definitely true. Now x raised to the power a, x raised to the power a would bring me to t raised to the power kab minus kac. This is x raised to the power a. X raised to the power b will bring me to, sorry, y raised to the power b will bring me to t raised to the power kcb minus k raised to the power, sorry, what am I saying? KCB minus KAB. Nice. And z raised to the power c will bring me t raised to the power KAC minus KBC. Again, this term and this term will cancel each other out when they multiply. This term and this term will cancel each other out. This term and this term will cancel each other out. So the product of them will also be equal to 1. Product of them will also be equal to 1. Will be equal to t raised to the power 0 or therefore 1. So 1 and 2 are definitely valid. So this option is out. All three of them remain. Now I have to check x raised to the power b plus c, x raised to the power c plus a, and z raised to the power a plus b. Okay. Can you see? Take one step back to x will be equal to x raised to the power b plus c is as good as t raised to the power k times of b square minus c square. K into b minus c into b plus c, which means this y raised to the power c plus a is going to be t raised to the power k times of a, sorry, c square minus a square, and z raised to the power a plus b is going to be equal to t raised to the power k times of a square minus b square, which essentially gets us to, again, when these three will multiply, every term will cancel out, kb square minus kc square, and ka square minus ka square positive, everything will multiply. When these terms multiply, I'll get t raised to the power 0, which is equal to 1. So this 3 is valid, which also means this 4 is not valid. This 4 is not valid. These three terms after multiplication will not give 0, they will give 1. So answer to the question will be option B. Next question. Now log x by something is equal to log y by something is equal to log z by something, then the value of blah blah blah. Let's go ahead. Log x by a square plus b square plus ab. You must have solved enough questions by now to see this expansion comes from a cube minus b cube wala world. Okay, is equal to log y by b square plus c square plus bc, which is equal to log z by c square plus a square plus ac is equal to k. The working is very similar. Is k. Okay. So now, hopefully, if I write directly x is equal to t raised to the power k into a square plus b square plus ab, it is not a problem. Or y is equal to t raised to the power k b square plus c square plus bc, or z is equal to t raised to the power k c square plus a square plus ac. And these things, as wonderful as they are, remember, these are not the terms. We have to multiply it with a minus b. So we'll have x raised to the power a minus b is equal to t raised to the power k times of a cube minus b cube. A minus b into this term will give us a cube minus b cube. Similarly, y raised to the power b minus c will get us to t raised to the power k times of b cube minus c cube, and z raised to the power c minus a gets us to t raised to the power k times of c cube minus a cube. Hopefully you can see when these three terms multiply, ka cube positive, ka cube negative, kb cube negative, kb cube positive, kc cube negative, kc cube positive, everything will cancel out. We'll get t raised to the power 0, which is equal to 1. So the value of this expression is 1. Final answer is 1. Okay. Now this, if a is equal to log 31, then whatever, this one is more observation based than any logic. Observation based. Can I say this is this 4 1 by 2 log 31, half of log 31. Now for log 31 to the base 2, this will be less than log 32 to the base 2 and will be more than log 16 to the base 2. Log 32 to the base 2 is 5. Log 16 to the base 2 is 4. So the value of this expression, value of this log 31 to the base 2 will lie somewhere in the range 4 to 5. So I can say the value of this expression will be 4 by 2 to 5 by 2, or it will be in the range 2 to 2.5. This is the value of A, or the range is identified as option B. Here simply you had to see 4 is a power of 2 and 31 is very close to a power of 2. Utilizing that, you had to come up with your expression. The precise value finding will of course not happen. Okay. Now this last question again. This is very similar to one of the earlier questions that we had done. Which one was that? Yeah, not this. Not even this. Where is it? This one. Whatever we had done here, precise same working we have to do in the last question as well. As in, the principles remain the same, not the precise working. Let us look at it. I have A is equal to 2 log 3 plus log 2 by 2 log 2 plus log 3. This is the value of A. This is the value of A. So what I'm choosing to do is I'm choosing to break these down. Can I write them separately? No. Can I write them separately? Because I see log 3, log 2. Okay, first let me work with this. This is log 16 by log 24 is 4 log 2 by 3 log 2 plus log 3. Okay. This by this. I know what I have to do. This will give me 4 by 3 plus 4 times of log 2 by log 3. 4 by 3 plus 4 times of log 2 by log 3. So I need a value for log 2 by log 3. I don't want a value of log 2 separately, log 3 separately. I need a value of log 2 by log 3. So I'm dividing every term here by log 2. Sorry, I'm dividing every term here by log 3. So I'll get 2 plus log 2 by log 3. Whole thing divided by 2 times of log 2 by log 3 plus 1. This is excellent. A is equal to this. Now I'm taking log 2 by log 3 as 1 or let's say k as k. So A is equal to how much? 2 plus k by 2k plus 1. So I'll bring it over here. 2ak plus a is equal to 2 plus k. So k times of 2a minus 1 is equal to 2 minus a, or k is equal to 2 minus a by 2a minus 1. K was log 2 by log 3. I can simply replace it here. Which will get me to 4 by 3 plus 4 times of 2 minus a upon 2a minus 1, or 4 by 3 plus 8 minus 4a upon 2a minus 1. So now I can multiply it here. I will get 8a minus 4 plus 24 minus 12a. Whole thing divided by 6a minus 3. I'm getting something like this, 6a minus 3. Okay. So I have 20 minus 4a upon 20 minus 4a upon 6a minus 3. This is very, very saddening. I must have made some mistake along the way. I will start. No, let me check my work first. This A is 2 log 3 plus log 2 by 2 log 2 plus log 3. Absolutely fine. Log 16 by log 24 is 4 log 2 by 3 log 2 plus log 3. Absolutely fine. Ooh, this is the error. No, I can't break it this way. This breakage itself is problematic. This breakage I cannot do. or when it is numerator, I can break it down into two parts. The denominator cannot be broken down into two parts. But again, I've taken log 2 by log 3. I can write it as 4k by 3k plus 1 by k, sorry, plus 1. This will become 4k by 3k plus 1. Now I have a value of k identified. Let me go ahead and put that 4 times of 2 minus a, and the denominator also I will put as 3 times of 2 minus a plus 2a minus 1. And then whatever is the denominator here and whatever is the denominator here, this portion and this portion, they will cancel out. So I don't have to worry about it. So this is simpler to do. I now have 8 minus 4a. Yes, I have more faith in my working because I'm getting something closer to the options. Then 6 minus 3a plus 2a minus 1, which gives me 8 minus 4a by 5 minus a, and therefore the answer to this will be option A. Answer to this will be option A. I made a tremendous error of writing it separately, but then this finally got resolved. Hopefully you learned something from the set of logarithm based questions. Log questions typically are the ones that help you become more and more proficient compared to other people, because log questions, there are log questions that are easy and there are log questions that are very difficult. And when people see difficult questions, they tend to ignore the entire topic altogether. Say modulus, logarithm, time speed distance, number systems, PNC. They carry a lot of baggage. Then these topics are the ones that separate somebody who's scoring very high from somebody who's going to score average. So hopefully you learned something. That will be all for this week. Okay, bye.